Observations from several telescopes, including Gemini South and NASA Infrared Telescope Facility, definitively showed us that the coma of this object is made out of at least water ice and potentially silicate grains.
Scientists have just announced that 3I Atlas, once believed to be a distant interstellar comet, might not be a comet at all. The discovery has thrown astronomy into chaos, rewriting everything we thought we knew about objects beyond our solar system. But if it's not a comet, then what is it really? The discovery that shook astronomy. On a seemingly ordinary day in early July 2025, astronomers at the Asteroid Terrestrial Impact Last Alert System in Chile made a discovery that would send shockwaves through the scientific community and capture the imagination of millions around the world. What they found wasn't just another space rock drifting through our cosmic neighborhood. It was something far more mysterious, far more enigmatic, and potentially far more significant than anyone could have initially anticipated. The object, which would soon be designated as 3I Atlas, represents the third confirmed interstellar visitor to enter our solar system in recorded human history. Now, you might be thinking, third interstellar object? That doesn't sound like such a big deal. But here's where things get absolutely fascinating, where the story takes a turn that has left even the most seasoned astronomers scratching their heads in bewilderment and wonder. Unlike its predecessors, 1I Oumuamua, which mysteriously tumbled through our solar system in 2017, and 2I Borisov, which passed by in 2019, 3I Atlas is moving at an absolutely blistering speed of approximately 58 to 61 kilometers per second, which translates to somewhere between 130,000 and 137,000 miles per hour. To put that into perspective, that's faster than anything we've ever recorded for an interstellar object before. It's screaming through space at velocities that challenge our understanding of how objects move through the galaxy, but speed is just the beginning of this cosmic mystery. When astronomers first spotted 3I Atlas on July 1st, 2025, they immediately noticed something peculiar about its trajectory. The object follows a hyperbolic orbit with an eccentricity of approximately 6.14, which is a technical way of saying that this thing is absolutely, unequivocally, not gravitationally bound to our sun. It came from somewhere else, somewhere out there in the vast expanse of interstellar space, and after its brief visit through our solar system, it will return to those cold, dark depths between the stars, never to return again.
Hello, wonderful person, this is Anton, and once again we're going to have to discuss the third interstellar comet discovered in the solar system, the comet 3I Atlas. The comet that was accidentally discovered just a few weeks ago, and the object that captured the attention of astronomers worldwide.
Now, here's where the controversy begins, where the story transforms from a straightforward astronomical discovery into something that has scientists, conspiracy theorists, and everyone in between engaged in heated debates across the internet and in scientific journals. Initially, when 3I Atlas was first detected, astronomers classified it as a comet based on early observations that showed what appeared to be a coma, that characteristic fuzzy envelope of gas and dust, and even what seemed to be a short tail. The Nordic Optical Telescope made one of the first confirmations, with observations conducted by respected astronomers David Jewett and Jane Liu, who definitively stated that they were looking at an active object with a diffused tail. Based on these observations, the object received its official cometary designation as C2025N1, even before scientists had fully confirmed its interstellar origins. Everything seemed straightforward, another interstellar comet for the books, a fascinating object to study, but nothing to cause particular alarm or confusion. But then came the deeper analysis, the more detailed observations, the careful scrutiny that revealed characteristics so unusual, so unexpected, that they forced scientists to question everything they thought they knew about this mysterious visitor. And that's when one name entered the conversation, a name that has become synonymous with controversial astronomical claims and sensational headlines: Harvard astrophysicist Avi Loeb.
The now somewhat controversial Israeli scientist Avi Loeb, the Harvard scientist that became super popular after his original proposition in 2017 that the first interstellar comet Oumuamua was potentially an extraterrestrial probe.
On July 16, 2025, Loeb published a preprint paper, not peer-reviewed, mind you, speculating that 3I Atlas might not be what it appears to be. He suggested, based on what he described as anomalous characteristics, that this object could potentially be some kind of extraterrestrial spacecraft, possibly even hostile in nature. Now, before you dismiss this as pure science fiction or conspiracy theory nonsense, let's examine the specific anomalies that Loeb and others have pointed out, because regardless of whether you believe his conclusions, the observations themselves are genuinely puzzling. First, there's the matter of size. Initial estimates based on the object's brightness suggested that 3I Atlas might be extraordinarily large, potentially up to 10 or even 20 kilometers in diameter, with a mass that could exceed 33 billion tons. That would make it significantly larger than any previous interstellar object we've observed. However, and this is crucial, Hubble Space Telescope observations later refined these estimates, suggesting the nucleus is actually much smaller, likely under 5.6 kilometers across. Still substantial, but not the massive anomaly initially thought. Then there's the composition, and this is where things get really interesting, where the chemistry of this object starts to deviate significantly from what we typically see in comets. Observations from the James Webb Space Telescope revealed an unusually high ratio of carbon dioxide to water, about 8:1, which is one of the highest ratios ever recorded in a comet. Most comets we've studied have much more water relative to carbon dioxide. Additionally, spectroscopic analysis detected atomic nickel vapor but no iron, which is genuinely bizarre because these elements typically occur together in natural objects.
Lack of identifiable chemicals. And this point was discredited almost right away. Observations from several telescopes, including Gemini South and NASA Infrared Telescope Facility, definitively showed us that the coma of this object is made out of at least water ice and potentially silicate grains.
The trajectory of 3I Atlas has also raised eyebrows among certain researchers. The object's orbit is inclined at approximately 5 degrees to the ecliptic plane, the plane in which Earth and most planets orbit the Sun. While this might not sound particularly significant, some have pointed out that this alignment, combined with close approaches to Venus, Mars, and Jupiter, seems almost too convenient, too perfectly positioned for a natural object. Loeb calculated probabilities as low as 0.0005% for such planetary alignments occurring by chance. But here's where mainstream science pushes back, where the vast majority of astronomers and researchers look at these same observations and come to very different conclusions. Because while the anomalies are real, while the unusual characteristics are genuinely present, the interpretation that this must therefore be artificial technology represents what many scientists consider a massive leap in logic, an abandonment of the principle that extraordinary claims require extraordinary evidence.
And so, let's go through some of these points one by one and see what the actual evidence says.
But the question remains, in the face of such unusual characteristics, how do we draw the line between healthy scientific skepticism and premature dismissal of unconventional ideas? And perhaps most importantly, what does this object actually tell us about the nature of interstellar visitors and our place in the cosmic neighborhood? Debunking the alien spacecraft theory. The moment Avi Loeb's paper hit the internet, suggesting that 3I Atlas might be artificial technology rather than a natural comet, the scientific community erupted in a chorus of criticism and concern, not because scientists are closed-minded or afraid of the possibility of extraterrestrial life, quite the opposite actually, but because the claims being made didn't match the observational evidence and the methodology being employed violated some of the most fundamental principles of good science.
Which brings us to that main question. So, why does Avi Loeb continuously push these narratives, even in face of obvious contradictory evidence? Why, Avi? Why?
Let's systematically address each of the major anomalies that have been cited as evidence for artificial origins, because when you examine them closely, when you really dig into the details and the data, a very different picture emerges, one of a genuinely fascinating natural object, yes, but natural nonetheless. Starting with the size estimates, which initially seemed so anomalous, so extraordinary, that they defied easy explanation. The problem with estimating a comet's nucleus size is that it's surrounded by a bright, active coma of gas and dust, which makes it incredibly difficult to separate the light coming from the solid nucleus from the light being scattered by all that surrounding material. Early observations, looking at the total brightness of the object, suggested it might be massive, perhaps 10 to 20 kilometers across.
For example, here are the images from Hubble, almost definitively showing us that this is a comet. Likewise, the observations from Vera Rubin Observatory that accidentally captured the comet even before it was officially discovered.
But here's the crucial detail that changed everything. When the Hubble Space Telescope turned its powerful gaze toward 3I Atlas, astronomers were able to much more accurately separate the nucleus from the coma. What they found was a nucleus estimated to be about 0.32 to 5.6 kilometers in diameter. Still a substantial object, certainly larger than your average comet, but not the impossibly massive anomaly that had been initially suggested. And critically, pre-discovery images from the Vera Rubin Observatory showed the object before it became highly active, providing a baseline measurement that confirmed this smaller size estimate.
And here the observations suggest a nucleus that's about 11.2 kilometers in diameter, or about 7 miles. And though obviously 7 miles is maybe a little bit large, and is definitely the largest interstellar comet we've seen, this is not the largest comet out there.
Observations comparing earlier images to more recent ones definitively showed that the object increased in brightness and developed a more pronounced tail as it approached the sun, exactly what you would expect from a natural comet responding to increased solar heating. There's absolutely nothing artificial about this behavior. It's Comets 101, basic solar system dynamics, playing out exactly as predicted by our understanding of how icy bodies behave when they get closer to a star. Now, let's talk about that unusual composition, because this is where things get genuinely interesting from a scientific perspective, where 3I Atlas reveals something important about the diversity of objects in our galaxy: the high carbon dioxide to water ratio, the presence of atomic nickel without iron. These are unusual, there's no denying that. But unusual doesn't mean impossible, and it certainly doesn't mean artificial.
Observations from several telescopes, including Gemini South and NASA Infrared Telescope Facility, definitively showed us that the coma of this object is made out of at least water ice and potentially silicate grains.
Multiple telescopes, including Gemini South and NASA's Infrared Telescope Facility, detected water ice and silicate grains, materials we find in comets throughout our solar system. The initial non-detection of certain gases like cyanides or hydroxides, that's actually completely consistent with comets at large distances from the sun. Comets become progressively more active as they approach solar heat. At the distance where 3I Atlas was first observed, it's entirely normal for some volatile gases to remain frozen and undetected. The high carbon dioxide content, while unusual, can be explained by the object's interstellar origins. Scientists theorize that 3I Atlas may have formed in a protoplanetary disk around a star with different chemical composition than our Sun, possibly in a region rich in carbon dioxide ices. The estimated age of this object, potentially 7.6 to 14 billion years old, means it could have formed in the early universe under very different conditions than comets in our relatively young solar system. Perhaps the most glaring error in the artificial origin hypothesis involves what Loeb described as smearing, or fuzziness around the object. He argued that what appeared to be a coma was actually just an artifact of the telescope's motion relative to the fast-moving object, causing it to appear smeared or elongated in images.
This is perhaps the most glaring factual error in his claims, and unfortunately seems to demonstrate some kind of a fundamental misunderstanding of basic observational astronomy.
This claim reveals what many astronomers consider a fundamental misunderstanding of how modern telescopes actually work. Professional observatories use a technique called non-sidereal tracking, where the telescope is programmed to follow the moving object itself rather than tracking the background stars. The evidence for this is crystal clear in published images. The background stars appear as trails because they're moving relative to the telescope's tracking, while the comet itself appears as a distinct, non-smeared, fuzzy object with an extended coma.
And the evidence for this is pretty clear in a lot of the published images, where the stars in the background are trailed, while the comet itself is distinct and appears as a non-smeared, fuzzy object.
Hubble images explicitly show this extended coma, directly refuting any claims that the fuzziness is merely an imaging artifact. As planetary scientist Michelle Bannister succinctly put it, "It has a coma. No large telescope has seen anything but a coma." The trajectory argument, while more nuanced, also falls apart under scrutiny. Yes, 3I Atlas passes relatively close to several planets, about 0.2 astronomical units from Mars and 0.4 AU from Jupiter. But here's the critical detail that often gets glossed over in sensational accounts. The object's orbit is actually tilted 175 degrees with respect to the ecliptic, meaning it's moving in a retrograde direction and inclined by about 5 degrees.
And while it's true that Atlas is going to pass relatively close to these planets, for example 0.2 astronomical units away from Mars and 0.4 AU from Jupiter, its trajectory is actually tilted 175 degrees with respect to the ecliptic.
There's nothing particularly anomalous about this trajectory when you consider the vast number of possible interstellar trajectories and the improved detection capabilities of modern telescopes. It will pass approximately 1.8 AU away from Earth, nowhere near close enough to pose any threat whatsoever. If this was some kind of artificial intelligence on a mission to Earth, as some have wildly speculated, why would it maintain such a large distance from our planet? Beyond simply disproving the supposed anomalies, there's actually substantial possibility positive evidence that 3I Atlas is a perfectly natural object. The comet appears to be coming from the thick disk of the Milky Way galaxy, an ancient stellar population hundreds of light-years above the galactic plane where our solar system orbits. Its high vertical velocity relative to our solar system can only be explained if it originated from this thick disk population, suggesting the object could be 9 to 13 billion years old, potentially older than our entire solar system.
And so the only real anomaly about this object is the fact that it seems to be coming from the really ancient part of the Milky Way, with the suggested age for this comet potentially now being over 9 billion years old.
The water-ice-rich composition observed in its coma tells us that this object very likely formed far from its parent star, possibly beyond what astronomers call the snow line, the distance from a star where water can condense into solid ice. It was probably ejected from that ancient star system billions of years ago, perhaps through a gravitational interaction with a giant planet or the passage of another star nearby, and has been wandering through interstellar space ever since. As we move into the final part of this investigation, we need to ask some uncomfortable questions. Why do these sensational claims continue to gain traction despite contradictory evidence? What does this say about the current state of scientific discourse and public understanding of astronomy? And most importantly, what can 3I Atlas actually teach us about the universe beyond the manufactured controversy? The real science and broader implications. To understand why the 3I Atlas controversy matters beyond just this single object, we need to examine the broader context of how scientific claims are made, evaluated, and communicated to the public. Because this isn't just a story about one interstellar comet, it's a story about the collision between rigorous scientific methodology and the allure of sensational claims, about the responsibilities that come with scientific authority, and about how easily misinformation can spread in our interconnected digital age.
Well, as many of his colleagues pointed out, since 2017, Avi Loeb essentially gained all of his reputation by making these extraordinary claims, or essentially making a lot of sensationalism, very often leveraging his Harvard affiliation simply to attract media attention and to then sell his books.
Avi Loeb's transformation from respected astrophysicist to controversial figure represents a fascinating case study. During the 1980s through the early 2000s, Loeb produced highly regarded work on traditional astrophysics, studies of the first stars, black holes, large-scale cosmic structures, and gravitational microlensing. This solid body of research earned him positions of great prestige, including a leadership role in Harvard's astronomy department. But something shifted in the mid-2010s. Loeb's focus moved toward more speculative topics, particularly the search for extraterrestrial intelligence and unconventional interpretations of astronomical objects. While SETI research is certainly legitimate science, the way Loeb approached it, through frequent media appearances, popular books, and preprint papers that bypassed traditional peer review, raised concerns among his colleagues.
But then something happened in mid-2010s. He suddenly switched to speculative and unconventional science, with his focus becoming interstellar objects like Oumuamua and search for extraterrestrial intelligence, but usually through somewhat unusual and controversial means.
The pattern became clear. Loeb would make extraordinary claims about astronomical objects being potentially artificial, generate substantial media coverage, and then publish books capitalizing on that attention. He did this with Oumuamua, claiming it might be an alien light sail. He did it again with supposed meteorite fragments recovered from the Pacific Ocean, which he suggested could be of extraterrestrial technological origin. And now he's doing it with 3I Atlas. The problem isn't that Loeb is asking unconventional questions. Science progresses precisely because people challenge conventional thinking. The problem is how he presents these ideas and responds to criticism. Rather than engaging with scientific critiques on their merits, refining hypotheses based on new evidence, or acknowledging when observations contradict his claims, Loeb often positions himself as a persecuted truth-teller, a Galileo figure being attacked by a closed-minded scientific establishment.
Apart from the fact that he's using his position to attract media attention and to promote his books, pretty much all of his recent papers never go any kind of a rigorous peer review and do not even get published because they cannot possibly pass scientific scrutiny. And though normally for a typical scientist you would usually try to correct your paper and possibly change your methodology just to make it, more scientific, for Avi Loeb his approach is playing victim.
Most of Loeb's recent papers on interstellar objects are posted as preprints, but never make it through peer review. That crucial process where other experts examine your methodology, check your calculations, and evaluate whether your conclusions are supported by your data. When these papers fail to pass scientific scrutiny, rather than revising them or acknowledging their limitations, Loeb typically posts blog entries portraying himself as a victim of scientific persecution. This approach does real damage to legitimate scientific inquiry. The search for extraterrestrial intelligence is an important, rigorous field that relies on extremely careful, objective investigation of every potential signal or anomaly. It requires evaluating all possible natural explanations before even considering artificial ones, consulting relevant experts across multiple disciplines, and being willing to discard hypotheses when evidence no longer supports them.
What Avi Loeb does right now is also unfortunately kind of detrimental to the larger field of SETI, Search for Extraterrestrial Intelligence, which is a legitimate and important scientific endeavor that entirely relies on extremely rigorous, objective, and scientific investigation of every single detection.
When someone with Loeb's credentials and Harvard affiliation makes sensational claims without following this rigorous process, it undermines public trust in science and makes it harder for legitimate SETI researchers to be taken seriously. It also creates a template for how not to do science, prioritizing media attention and book sales over careful analysis, using prestigious affiliations to lend unearned credibility to speculative claims, and dismissing criticism as persecution rather than engaging with it constructively. But let's set aside the controversy and focus on what 3i Atlas actually tells us about the universe, because the real science here is genuinely fascinating, potentially more interesting than any artificial origin hypothesis could ever be. This object provides our third data point for understanding interstellar visitors, and each one has taught us something different about the diversity of objects wandering between the stars. Oumuamua showed us that small, tumbling objects can traverse interstellar space. 2i Borisov demonstrated that some interstellar visitors are active comets very similar to those in our own solar system. And now, 3i Atlas reveals that ancient comets from the early universe, potentially billions of years older than our solar system, can survive their lonely journey through the galaxy. The object's unusual chemical composition, high in carbon dioxide, containing nickel vapor, depleted in certain carbon compounds, tells us about conditions in the protoplanetary disk where it formed, possibly around a star with very different metallicity than our Sun. Its age, estimated at 7 to 14 billion years, means this is quite literally a time capsule from the early universe, carrying pristine material that predates the formation of our entire solar system. Future observations, particularly from the James Webb Space Telescope in December 2025, will allow scientists to study the detailed chemical composition of this ancient visitor, potentially revealing elements and isotopes that can tell us about stellar nucleosynthesis and galactic chemical evolution billions of years ago. Mars orbiters captured images during the October 2025 flyby, and Jupiter probes may get closer looks in early 2026. Beyond this specific object, the detection of 3 interstellar visitors in less than a decade tells us something profound about the universe. These objects are far more common than we previously thought. Improved detection systems like Atlas, Pan-STARRS, and soon the Vera C. Rubin Observatory are revealing that our solar system is constantly being visited by wanderers from other star systems. Statistical models suggest there could be one interstellar object within the orbit of Neptune at any given time. This has profound implications for understanding planetary system formation and evolution. Every star system, it seems, ejects vast numbers of objects during its formation. Planetesimals, comets, asteroids that then wander through interstellar space, potentially carrying water, organic compounds, and even the building blocks of life between star systems. The theory of panspermia, that life's precursors might spread through the galaxy via such objects, becomes more plausible as we realize how common interstellar exchange actually is. The 3i Atlas story also highlights the importance of media literacy and critical thinking in the age of viral misinformation. Sensational claims about the object spread rapidly across social media platforms, including an anonymous 4chan post purporting to be from an ESA researcher claiming the object was a cue ball or quantum relic rather than a natural comet. YouTube videos accumulated millions of views, with titles claiming scientists were hiding the truth or that the object was an alien mothership.
At like 130,000 miles an hour.
No, that might solve all our problems.
Some intergalactic object that's...
Celebrity podcasters like Joe Rogan amplified these claims, discussing the possibility that 3i Atlas might be an alien probe without adequately presenting the scientific consensus. While entertainment and speculation have their place, the line between what-if scenarios and what is reality reality can become dangerously blurred when influential voices don't clearly distinguish between evidence-based conclusions and wild speculation. The lesson here isn't that we should dismiss unconventional ideas or avoid asking bold questions, quite the opposite. Science advances precisely because people dare to question conventional wisdom, propose new hypotheses, and challenge existing paradigms. But there's a right way and a wrong way to do this. The right way involves careful methodology, transparent data sharing, honest engagement with criticism, and a willingness to revise or abandon ideas when evidence doesn't support them. As we continue to observe 3I Atlas through its perihelion passage on October 29, 30, 2025, and as it makes its way back out toward interstellar space, we have a unique opportunity to study an ancient visitor from the early universe. The real discoveries to be made here about galactic chemical evolution, planetary system formation, the survival of volatiles over billions of years are every bit as exciting as any science fiction scenario, and they have the added benefit of being real. So what's the final verdict on 3I Atlas? All available evidence points to this being a natural interstellar comet, albeit one with some unusual characteristics that reflect its ancient origins and the different chemical environment of the star system where it formed. It's not an alien spacecraft, not a quantum relic from the Big Bang, not a threat to Earth, just an extraordinarily old piece of ice and rock that has been wandering between the stars for billions of years and is now briefly passing through our cosmic neighborhood before continuing its eternal journey through the Milky Way. The anomalies that seemed so mysterious initially, the size, the composition, the trajectory, all have perfectly reasonable natural explanations when examined carefully by experts using proper scientific methodology. The supposed lack of cometary features was simply due to observing the object at large distances where activity is minimal. The unusual chemistry reflects formation in a different stellar environment. The anomalous trajectory is statistically rare but entirely possible given the vast number of interstellar objects and improved detection capabilities. What 3I Atlas really changes isn't our understanding of alien civilizations or interstellar technology. It changes our understanding of how common interstellar exchange is, how diverse the chemical compositions of objects from different stellar environments can be, and how much material from the early universe is still wandering through our galaxy, occasionally dropping by for a brief visit.
This is still a field in its infancy. We only have 3 objects, and so calling any of these objects anomalous is completely unfounded.
The field of interstellar object studies is still in its infancy. We've only confirmed 3 such visitors, and as detection systems improve, we'll likely discover many more. Each new discovery will expand our understanding of what's possible, what's typical, and what's genuinely anomalous. But jumping to extraordinary conclusions based on limited data, bypassing peer review, and leveraging institutional prestige to promote speculative ideas, that's not how good science is done. The real story of 3I Atlas is a story about the importance of scientific rigor, the danger of sensationalism in science communication, and the genuine wonder of discovering that our solar system is constantly being visited by ancient wanderers from across the galaxy. It's about recognizing that the universe is already far stranger and more interesting than any artificial explanation we might concoct. As we watch this ancient comet continue its journey back into interstellar space, carrying with it material that formed billions of years before our sun even existed, we should feel a sense of profound connection to the larger cosmos. We're not isolated in our little solar system. We're part of a galaxy-wide exchange of matter, energy, and potentially even the building blocks of life itself, and we don't need to invoke aliens or spacecraft to feel that sense of cosmic wonder.
But we will be focusing on this particular comet in some of the future videos, especially once we have observations from the James Webb. And so on that note, thank you for watching, subscribe, come back tomorrow to learn something else.
The coming months will bring new observations from JWST and other telescopes, potentially revealing even more about this remarkable visitor's composition and origins. And as our detection systems continue to improve, we'll discover more interstellar objects, each one teaching us something new about the galaxy we inhabit. The universe doesn't need manufactured mysteries or sensational claims to be fascinating. It's already more extraordinary than we can fully comprehend. We just need the patience, rigor, and intellectual honesty to study it properly. That's the real lesson of 3I Atlas, and that's what makes science so much more powerful and meaningful than pseudoscience could ever be. If you enjoyed watching this video, then go ahead and click on any of the cards on your screen for more.